Hello, good day. I am Miss Gina Arcelia, your technology and livelihood education teacher in grade 10. Tara, let's explore lifelong lessons in today's episode. Are you ready? So welcome to our cookery class. Our today's topic has something to do with the introduction of starch and cereal. And with that, let me start by stating the most essential learning competency of our lesson, and that is to identify the ingredients in the preparation of various types of starch and cereal dishes. You have to stay focused because we are going to talk about lots of things about starch and cereals. These are our objectives. First, you are going to identify the sources and kinds of starches, followed by its composition and structure. You also have to know the properties and reactions of starch. And lastly, know its nutritive value. Let us now give the definition of cereals. When we say cereals, they are usually starchy pods or grains. Cereal grains are the most important group of food crops in the world. Rice, wheat, and corn are the most cultivated cereals in the world. Now let's move on to the classification of starch. The parts of plant that store most of the starches are seeds, roots, and tubers. There are three kinds of starch. We are going to discuss them one by one. Let's start with the native or natural starch. This refers to the starches as originally derived from its plant source. This means there is no alteration or modification that happened to the starch. It's like you just eat sweet potato or corn or any fresh cereal or grains. And from that, you can get the natural starches. The second kind of starch is called modified starches. This means something has been changed from its natural source. For example, you cook rice. There is already physical or chemical change that happened, and that is considered as modified starch. The last one is called purified starch. This procedure employs various techniques of grinding and screening. That is to separate starch from fiber, oil, and protein. And to give you more information of the starch in cereals, let us discuss its structure and composition. There are two types of starch molecules. They are called amylose and amylopectin. Amylose is a long chain-like molecule, sometimes called the linear fraction, and is produced by linking together 500 to 2,000 glucose molecules. What is its function to food? It is responsible to gelling characteristics of starch when they are cooked and cooled. And on the other hand, we also have amylopectin. Amylopectin has highly branched, bushy type of structure. Cohesion or thickening properties are the contribution of amylopectin when a starch mixture is cooked in the presence of water. Want to learn some more? Okay, let's find out the properties and reactions of starch. The first one is called gelatinization. This means this will take place when starch absorbs water and be heated. Once the starch is combined with water or any liquid ingredients, then heated, the process is called gelatinization. Next, we have viscosity, or the resistance to flow. This means to increase in thickness or consistency. When newly gelatinized starch is stirred, more swollen granules break and more starch molecules spills, causing increase in viscosity or thickness. This reaction is the result of its amylopectin content. When starch and water has combined or was combined and can be stirred, it is viscosity. Example of this is butter or pancake mixture. Though the mixture is thick, still it has the ability to flow. The third properties and reactions of starch is called retrogradation. This means losing of water or moisture content after gelatinization. For example, in making bread, retrogradation expels water from the bread structure. Water will then evaporate and at suitable conditions to leave the bread structure, causing the bread to lose moisture. Hence, the bread will be more dry and become undesirable in terms of taste. Next, we have cineresis. It is the shrinkage of a gel and subsequent loss of moisture or liquid. Gels affected by cineresis more quickly if exposed to protein. An example of this is lemon meringue to starchy lemon meringue. Filling reacts to cineresis quickly because it is exposed to protein in the meringue. Another example of cineresis is a scrambled egg, which, if overcooked, shrinks and produces liquid. Now, let's have dextranization. Best example of this is when we are going to prepare brown sauce or gravy, where flour, an example of starch, were toasted first or pan-fried first without any fat or liquid content. When it becomes brown in color, the process is called dextranization. And lastly, we have hydrolysis. This is promoted by prolonged heating of starch with acid. This can be happen when cooking an acidic food such as pineapple pie, resulting to firmness of pie filling. And that is our lesson for today's episode. I hope you've learned a lot. Always remember, at TLE, we keep on going beyond the traditional. Bye-bye!